Okay, so this video is not on these radios. I have got hundreds and hundreds and hundreds of video clips at any given time that I need to get edited together, merged together, and then get uploaded to YouTube. And right now I've got, I think it's like 400 gigabytes worth of video files, probably well over 100 separate videos once I get the, all the video clips merged together. This video is on a Bearcat DX1000. I either, which I don't think happened, I either forgot to push the record button on the camera, or I think what happened is I just lost a video clip somehow. I don't know if it didn't get transferred from the SD card on the camera here over to the computer, but I've got a video clip before that, the previous radio I'd worked on, and then I've got the clip where you'll, after I get done yammering on here, you'll see where the video actually starts. The file number in between those two, it's just, I don't have it. I don't know where in the hell it's at. So, yeah, there's some lost footage. So what the customer had, I basically need to describe what's in that missing footage. There's still lots of good repair stuff in this, because the initial diagnostics was only a small portion of what was wrong with this receiver. The customer had been away. Apparently there had been a thunderstorm or a lightning storm had passed through. He turned the receiver on, and it was deaf. So I don't think it was a lightning strike. It's probably just a high ESD event. Static buildup on the antenna, and it's what it did was zapped the first amplifier. So it's a dual. God, it's been a long time ago that I'd recorded that video. I think it was a dual FET, and I had replaced that. So, or in where the video starts at, you'll see the video. That circuit board is actually out and in a circuit board vise, and I'm working on it. I'm replacing the electrolytic capacitors, removing glue and whatnot. But yeah, that's what's in that footage. Is basically basically first testing the radio. Yeah, it's deaf. I went through signal tracing. Like I say, unfortunately, that video footage is lost. But there's lots of other problems in this thing. The first amplifier wasn't working at all, so I had replaced that dual FET. It did start receiving, and like I say, you'll see that in the video, because actually that's afterwards. But it had problems. It had other problems. Lots of other parts got damaged too. So I go through in detail in later bit of this video, troubleshooting that and actually finding all of those other bad parts. So let's let the video start where the the footage that I do have. Okay, so I got to go ahead from the customer of this, the DX1000, to do the full cap job, remove corrosive glue, which there's not a lot of in these, but any glue is bad glue. So we'll get rid of that, and then do a receiver alignment on it. One of the advantages of working on not all, but many receivers and amateur radios is, and it's not always the case, but more often than not, you can do something like this. Take the circuit board out of the radio. And this makes working on it so much easier. Now, of course, you can't really do any diagnostics, so when you're doing your diagnostics, the board would need to be in the radio. But when you're doing major overhauls, replacing all the electrolytic capacitors, it's really a pain. Working on CB radios, you've always got them standing up on end, and it's just a pain in the butt. Stuff like this is really easy, because now granted, there are a boatload of connectors you have to unplug from this thing, but once you unplug all of those, there's only 2 wires that are soldered down. Those were the ones that I had just temporarily tacked back in to test the radio to see if replacing that dual gate FET repaired it, which it did. But yeah, 2 wires and then just a bunch of plugs. I already had the screws out because I was working on it, and there it is. So now the board's out, I can stick it in a board holding vise, and so easy to get into this thing now. I don't have to worry about it falling over. I can come in from one side with the desoldering iron, come in from the other side, pull the part out, slap a new one in. It just, yeah, speeds up the process so much. So there's like I say, there's not a lot of glue on this one. There's, tilt it down here some. Yeah, there's going to be some around the large capacitors. You can see there's some smooshed out there. There's going to be some around these caps. Let's see, I think yeah, there's a little bit here by this it's just a piece of wire with a little ceramic standoff. That's one of the test points. There's a little bit of glue there, but yeah, it's not an excessive amount. So yeah, luckily, and it hasn't degraded really bad, so it's not to that point where it's eating everything off of the board. So anything that it is touching, it should be fairly easy to get off, because I can feel that it's still kind of rubbery. I doubt you can hear that in the camera, but when I push this over it, it's kind of squeaky. So that's always a good sign when it's still nice and juicy, as I say. But so let me get the cap job done. Now the other, remember, this is only one half of the radio. Of course, this is one circuit board on one side of the radio. And let me just make room here, and we'll get the rest of the chassis up here. So here's the side that I have now taken out. So, but yeah, like I say, just lots of plugs, which, like I say, now these are numbered, so that's one advantage here. They did number all the plugs, and those numbers do correspond to a CN number on the main board. So yeah, I'm not going to say you couldn't plug the wrong plug into the wrong socket, but as long as you pay attention to the numbers, you won't have a problem. The other side, or the top side, not a lot of electrolytic capacitors up here. I think there's only, what, one on this main board? Yeah, there's one there. It seems such a shame. Now, I won't completely remove the board out this one, since there's only one. I'll just fold it, probably this way up. But yeah, I do have to take these out. There's probably some, haven't had the can covers off yet, so I'm not 100% sure. Get this cover off. Yeah, there's a bunch in that can. And can I even get this one off? No, not with the bracket in the way. There's another RF shielding can that runs the opposite direction under here. Should be some caps in that. And actually, that's on this main board. So yeah, there may actually be some more on the main board. But yeah, it's not too bad. Yeah, this board easy to come out. Just a couple screws, I'll be able to. Again, everything's done with plugs. Makes it, everything's done with plugs. A couple screws, and the whole board just comes out. So yeah, again, easy to work on. Is that, let me just swing the camera out of the way here for a second. I guess that was just missed solder mask. I saw something that looked a little strange down there, that spot. Now what you're seeing in there, that's the reflection. But yeah, it looks like I thought it was a big corroded spot. No, actually it looks like when they silk screened the circuit board, they missed silk screening it, but it did get tinned. So, no worries there. So anyhow, let me get to it. One other thing, I think I forgot to mention this earlier about this radio, was the actual tuning on this. It uses a photo transistor setup, actually a dual photo transistor. So on one side you'll have an LED, and then on the other side there's actually a photo transistor. But you can see there's a pair of them, and then you just have this transparent wheel that the light shines through. And anytime one of these little black spots passes by the photo transistor, it'll block it. But then, and then having two of them, it can keep track of timing, and how fast you're turning. But yeah, that's actually how the tuning's done in this. That's your tuning knob. It's not actually physically attached to anything. There's no connection. There's just a big counterweight here, to give it some mass, some feel, because it's just a very thin plastic knob. So they put a big weight on the inside. Like I say, that makes it feel like a big heavy knob when it's actually not. And just a clear plastic disc, that's it. It has no other mechanical connections other than its pivot point where it's screwed to the front of the chassis. And it just kind of hovers in between those two little photo transistors down there. So that's the encoder system on this. Not an encoder like you would think of normally in a mechanical style encoder. This is an optical. Well, yeah, I guess you'd call that an optical encoder. Like I say, photo transistor, so yeah, that would be optical encoder. So, let me get to it. This radio is testing my patience. So, have replaced the first RF amplifier that was shorted out, and I initially thought that got my receive back. Well, it did, but only in one band. This radio has, what, 1, 2, 3, 4, 5, 6 in the non-tunable, so seven bands. And it's not like you're changing a control. It's just as you change frequency, once you get to the end of a band, the microprocessor switches the receiver circuitry for bandpass filtering to a different circuit. But the band that I had initially tested it on, radio seemed to be working okay. It is a little bit low still on that band, but it's when I went to do the alignment, because I did that, I replaced all the electrolytic capacitors, reinstalled all the circuit boards. So I've soldered all of the RF shields onto the bottom of the circuit board, got it all back together here. Need to do the alignment now, and I had aligned all the synthesizer circuits. Set all of the VCO voltages in this, which is a bit of a process on these, but got all of that done. Adjusted the FM receiver circuitry, adjusted the main receiver sensitivity circuit and the filter network, because remember this has 3 different IF bandwidths you can user selectable from the outside of the radio, and basically all that does is then selects one of these filters back here. It just enables one of these filter circuits. So got that done, and one of the last things you actually do in the receiver alignment portion of it is to adjust this bandpass filtering here. So this is actually it's actually before the front end amplification even happens. They have a bandpass filter. So you have your antenna jack, which is selectable depending if you're using a high or low Z antenna. Goes through the switch right here that selects which antenna type you're using. Comes in, you have the attenuator. So if you want to, if you're listening to somebody really close, you can put in some attenuation, but then it gets selected by the microprocessor through the wires coming through this connector right here. There are 7 pins on this connector, and depending what band the microprocessor sets the radio into, it energizes one of those pins, which in turn applies power to the base of a transistor that's for each one of the bandpass filter circuits. That transistor turns on, which then forward biases a diode that allows the signal to pass through that tunable transformer, and then there's a parallel tunable trimmer capacitor down here. Then the signal comes out, goes through a little bit more stuff, but then comes through to the first RF amp. So actually, let me just pause the video and we'll look at it on the schematic. Okay, so hopefully this shows up okay. So here's your antenna jack. They're actually selectable. You can either use the 500 ohm or the 50 ohm, and then that's selectable by the switch on the back side of the radio. Comes through your attenuator switch, so you can select 0, 20, or 40 dB of attenuation. And then from here, the signal gets split up and down. This is I guess would be what you'd call the VLF band. Covers from like 10 kilohertz to I think 149 kilohertz is this filter network up here. And then for all the other bands you have down here. But here's our tunable transformer and trimmer capacitor. So there's 7 of those total, or 6 of those total, and then you have the 7th band up here, which is just they use fixed values. That's not tunable. So here's the connector over here with all of the wires on that plug I was just showing. It applies power to the base of one of these transistors. That transistor turns on, which in turn, basically in the long run, you end up forward biasing these diodes right here, and then the signal can get through these tunable circuits out and then into the first RF amplifier. And this is the dual gate FET that I had originally replaced. So I have been pulling my hair out on this radio because I went to do the alignment to all of these circuits right here, and the only thing I could get tuned properly was this one here, this bottom circuit, which covers actually a large majority of the band. Let me grab the block diagram here. That covers from 12.757 to 30 megahertz. So that's all done with this one tunable transformer and capacitor here. And then each of these does a different chunk of the band. This is the only one that had at least halfway decent receive. I could get this one adjusted to about minus 110 dBm receiver sensitivity. Not great, but acceptable on a cheaper radio, but it should be better on this one. As we went down in receiver frequency though, so every time I'd go down in bands, the receiver sensitivity got worse and worse and worse. And by the time you got to the lowest band, like I say, that goes from 10 kilohertz to 149 kilohertz, I had to shove like minus 55 dBm in the antenna socket to even, excuse me, to be able to hear anything. Let me get a drink. Starting to sound like Kermit the Frog there. So I have spent a considerable amount of time just scratching my head here. This is a very simple circuit. Very simple. And if you ignore, because you have to remember, now I checked the base voltage, so the voltage being supplied to these transistors, they were all fine. All of the transistors were working just fine. I did some signal tracing with a spectrum analyzer. You could check at, from basically from the antenna jack to the output of these tuned circuits. Looked okay here, but the farther you got down, actually when you'd hook up the probes to the inputs of these tuned circuits, the signal had already been dropped down by the time you got here. And I'm just looking at it and, kind of in the back of my head, I think there was a little guy yelling, "Don't forget this had a high ESD lightning event." And it's finally when the light bulb went off in my head. What other semiconductors or what other parts could easily be damaged by an overvoltage if there had been a high ESD or electrostatic discharge event? The FET got blown out. Well, if that FET got blown out, the only way for that energy to get to this device was to come through this circuit here and work its way up through. So it had to pass through all of this stuff. What other semiconductors do we have in here? Now, if it was ceramic capacitors and resistors, yeah, I can pretty much 99.9% of the time they're not going to be bad. If a ceramic capacitor takes an overvoltage, usually a dipped ceramic capacitor will just vaporize. You'll have two pieces of wire sticking up off the board if you overvolt a ceramic cap. They go from working perfectly to pop, they just split in half. Same thing with a resistor. If it had been one of the carbon film resistors, I would have expected to see a burned resistor. The transistors were fine, and the switching circuit was working fine too. So the only thing really left was these diodes that get biased, forward biased to get turned on to allow the signal through these tuned circuits. Sure enough, that's the problem. Every single one of those diodes is shorted out except for that one. And this is the band where it's low, but I think a lot of it's just being synced to ground because all of these are shorted out. Yeah, that's my problem. Every single one of those diodes is shorted. So let me get back over to the radio here and we'll take a look at that. Okay, so back to the radio here. So these diodes, or as Dave Jones at the EEV blog, as he always says when he was a kid, because he didn't know any better, he used to call them diodes. So these are the diodes right here. Here's our switching transistors. So the microprocessor selects which band pass network here it wants to use, supplies voltage to the base of a transistor, which turns on, which then forward biases the diode. These diodes are the diodes that are fried. The only one that's any good is, it's actually just out of camera view, it's here, and it's right here. That's the only one that's there. It might be, maybe it's this one. Yeah, actually I think it's that one's the one that's good. Yeah, all the rest of them are bad. So what I did to diagnose those was, now ideally testing a semiconductor in circuits, kind of a half-assed way of doing it, I guess the best way to put it, because you're going to have resistance in the circuit. But if you hook up an ohm meter across the diode, forward bias it, with your probe, and then flip your probes around to reverse bias it, you should see a difference there. It may not be the reading you would expect to see if the diode was sitting on your bench out of circuit, but you should see a resistance difference between forward and reverse bias with your ohm meter probes. And that's not the case here. So let's get zoomed out here. You look over at the multimeter there. I'm going to have a heck of a time because the camera is right in my way here. So I'm going to see if I can do this without moving the camera. Okay, so there, that would be what? That would be forward biasing the diode. So I had the positive ohm meter lead attached to the anode and the negative attached to the cathode. And you can see it's 40 ohms. Let me get the leads flipped around here and try and get attached here again. Oh, for Pete's sake, stay on there, probe. And look at that, reverse bias, exactly the same, 40 ohms. So, you know, I sat there and looked at the schematic for a while, and I thought, well, is there somewhere where that could be shorting elsewhere? And I was, well, there's an easy way to tell. Just cut one of the diodes, because luckily, you can see these diodes are installed standing up. You can't get to the bottom side, but luckily this, I was actually probing from this resistor right here to the lead, because you can't get to the bottom side of the diode to stick a probe. But like I say, this resistor, you can see the printing on the board here that those are common connected together. But an easy thing to do is just snip the lead of one of them. So that's exactly what I did. So this one right here, you can see I have cut the lead. Okay, and again, we'll go back to the ohm meter. And we'll check that one, because that diode is now completely out of circuit. One end is attached, but the other end is just floating in midair. So no component inside this radio is going to affect the readings that we're getting. So again, get from there. Right on there. Yeah, that, now this is, remember, this is a different diode. Oh, move my probe lead a little bit. So this one's 67 ohms. And if I flip the leads around the other direction, if I can get my lead on there, again, 67 ohms. The diode's bad. Every stinking single one of those, well, all but one, the one for the highest frequency band, they're all shorted out. So I gotta pull the board out again. So probably the moral of the story here is, a lot of times, just don't give up. I was right there. I was balancing on a knife edge. You know, I've had it. I can't take this radio anymore. My best advice, and trust me, from lots of experience of hitting that brick wall of you just can't figure out what in the heck is wrong, is take a break. It may be just as simple as go get a cup of coffee, go do something, or just set the radio off to the side and work on another radio. You know, do something that you're just maybe replacing electrolytic capacitors in, or just do a simple job, and then come back to your radio with a fresh set of eyes. You'd be surprised how many times you'll have, because like I say, this is a fairly simple circuit. There's not a lot of parts here in this band fill, and I knew the problem was right here, because the signal was getting in, but it wasn't getting out of this circuit, so it had to be here somewhere. But like I say, sometimes you just hit that brick wall where even if it's a blaringly obvious problem, you just for some reason ain't seeing it. So yeah, don't get frustrated. That happens. You know, you'll get to a point when you work on a radio or a television or a computer or anything, as a matter of fact. It can be a vehicle. You get to a point where just because something is, you'll get to a point in diagnostics where it should be simple to find. Your brain, it's not just you personally get frustrated, your brain is frustrated. It's tired of working on whatever it is you're working on, and your brain just shuts off. You know, out to lunch sign hanging in the, you know, bouncing around in your head somewhere. So go take a break. A lot of times you'll come back and very quickly find what the problem is, and you know, you'll do it, slap your head. You go, oh my God, it was so simple. I should have seen that before. Or in the case, I was right there. I was about to say, okay, I'm going to set this off to the side, do something else, and then I'll come back to this. And that's when it dawned on me. I hadn't checked those diodes, and I'm glad I did, because yep, there's the problem. So now I got to pull all of the plugs back out again, pop this flex ribbon out that controls the attenuator switch there, desolder those couple wires, take the screws out, pull the board out. I have to completely desolder because I had this radio put back together ready for alignment, so all of the RF shields have been resoldered on the bottom side of the board. So there's a big RF shield, that big silver thing you see right there. That's a big RF shielding plate that covers this entire area right here. So, and it's got solder connections the whole way around it. It's just edge soldered to the circuit board, so I have to completely desolder that again so I can get in there to remove those diodes. But that should fix it, because that's basically, I was almost done the alignment. Like I say, had all of the synthesizer circuit done. I had all the frequencies adjusted on this side. I had the FM circuit, all the AM circuit, or actually AM, because this is all this receiver sensitivity adjustments here cover AM and sideband. Had all of that done. Basically, the last thing to do was adjust the bandpass filtering prior to the front end amplification, adjust the automatic gain control circuit, meter, and a couple last little things, and I'd have been done. But yeah, so I gotta rip her apart, put it back together again, and then continue on. Luckily, nothing that I'm doing here is going to affect any of the work that I've previously done, so I don't have to redo any of that, thank God. But there you go. So yeah, like I say, a lot of times you run into a problem, just take a break. You'll trust me from speaking from experience. The brain needs a break every once in a while, and the longer you stare at something, the harder it gets. And the more you study it, the less sense that it makes. You'll take a break and come back, and in a minute, you'll just, like that, the light bulb flashes over your head and you've found the problem. So let me get those replaced, and we'll be back again.
Dedicated this book, Bandit Britain, very simply.
Now that was something I couldn't do before. Listen to AM broadcast radio. Now it's the middle of the night now, so all of the local stations have powered down. That's actually a skip channel coming in from, I didn't have it on long enough to get a call sign, but from somewhere else in the United States. But yeah, so what I did was I actually removed every single diode out of the bandpass RF can there. I showed you that row where the bad ones was. I just replaced every diode in there. There was a total of 14 diodes. I tested all of them once I had them out, and 7 of the 14 were bad. So even if I had only had maybe 2 or 3 bad, I still would have replaced all of them. That's one of those things, if just a couple got zapped, what's to say that the rest of them aren't hanging on, they're on their last legs and ready to go kapoof. So yeah, I'm not going to take a chance, especially having had to pull that board back out, take the RF shield, desolder it off the bottom of the board again, go through all that work, and then find out, there was another diode goes bad, a week after the customer gets it. So yeah, penny a piece parts, just replace the rest of them. So after I did that, got the board, before I soldered the RF shield back in, just laid the board down, plugged all the connectors in, turned it on. Yeah, as soon as I turned it on, I heard noise low on the dial, and I was like, yep, that fixed it. So did a little bit more testing that time to make sure that it was okay. Soldered the RF shield back on, then reinstalled the board, and yes, it's fine. So I was able to finish the rest of the alignment on this, and it's working like it should now. I don't think I went completely over the controls on this before, so I had mentioned the filters, but we'll just start left and go right. Has a dimmer switch which controls the brightness of the indicator LEDs, the display, and the meter. You have your 3 selectable IF filters from 2.7 to 6 to 12 kilohertz. So normally you'd use your 2.7 for sideband or CW, your 6 for AM, and usually 12 kilohertz if you're doing FM. But there's not a lot of FM usually you're going to be listening to in the HF band. Usually it's going to be AM or sideband or CW. Does have a noise blanker that it has a selectable fast or slow setting, and then the AGC also has fast and slow, so if you're using AM or sideband, it's nice to be able to change the AGC speed. And then it has the step button, which controls how fast this changes the frequency. So let's see, yeah, I'm in manual right now, or dial, so it has a key and dial. So if you put it in key, the knob does nothing. That makes the keypad enabled, basically. And if you put it in dial, then the dial works. But the keypad, as you can see, no longer beeps. It doesn't do anything. When you push, if you have this button out, you can see just a tiny little bit of movement of this dial changes it in 1 kilohertz steps. If you push that button in, you'll see that you get quite a bit of rotation for 1 kilohertz. So now you're going, and if you actually had a signal on like in sideband, you'd hear there's actually 10 steps in between, because you're actually changing in 100 hertz steps. It just does, the frequency counter doesn't have a 100 hertz position. Other buttons up here on this keypad, you have your AM, lower, upper sideband, CW, FM, the manual, you know, it sets to either keypad or the manual. Most everything else here either is for memory channels, setting the times. You know, if I turn the radio off, you'll see the display is just blinking zeros. That's because I have not set the clock on this. Then you have 2 time zones. You can set that to time zone 1 and time zone 2. So yeah, most of this is for setting memory channels, doing the clock and whatnot. You've got the RF attenuator, so this does not have a normal rotary RF gain control. It just has a 0, 20, or 40 dB attenuator. Have a dual function control here, your volume and tone control, fine tuning, squelch, and the knob. That's pretty much it. You know, it's a basic radio. It's not one of the uber high-end expensive ones. You know, it's got phenolic circuit boards. They're not high-end fiberglass circuit boards. Some people say these things are junk. Other people love them. It's a middle-of-the-road radio. So, you know, if you're used to using an uber expensive shortwave or HF, you know, receiver, yeah, this is probably going to be substandard to you. If you've been using a cheap radio and you've upgraded to this is probably going to be an impressive radio. Like I say, it's a middle-of-the-road radio. It wasn't horribly expensive when it was made, you know, compared to the high-end radios, but it was considerably more your little small shortwave style radios. So now that this one's back up and running, I can pull the tape off the bezel, clean the faceplate up on it, put the cover back on it, and actually I got to bundle up some of the wire tie. Guy had to clip a few wire ties off, so just a few wire ties to add to this thing, and then I put the cover back on it and get her boxed up and sent back. So there you go. If you ever have and it doesn't necessarily need to be a Bearcat DX1000, it's just what I repaired specifically pertains to this radio. But if you have an AM radio, your shortwave, you know, radio, a receiver, a transceiver, I mean, actually, Buddy and Peter, I think both within a few weeks ago, I think, both had a Linko, and I think both of those were dual band mobile radios, if I'm not mistaken. Don't hold me to that, but I think they both had dual band rigs on the bench, and they had the same exact problem. Now those were transceivers, so you know, transmitters and receivers, but they had the exact same problem this had. The first RF amp was bad. That's a common problem. Lightning storm passes through, and you do not need a lightning bolt to make contact with your antenna to have this happen. You get a high buildup of static electricity on your antenna, you know, not a direct bolt up, you know, from the sky to the ground, but you just have a high buildup of static electricity on your antenna, and it comes down through your cable, you know, into your radio. It doesn't take much to take out a FET. So, you know, field effect transistors are very, very sensitive to static. Now this one had the diode problem, but if you've got any type of radio, you know, you left one day, your radio was working, you come to use it the next day after a lightning storm passed through, and it doesn't receive anymore, really good chance your first RF amplifier is bad. There's no guarantees that's, you know, it is, and there's no guarantees that's the only problem, as you saw in this one. But yeah, usually the front end, and when you hear people say that, front end, what they mean by that is when I had the schematic I showed, you know, up on the computer monitor screen, the bandpass filter network over to the first RF amplifier, that's the front end. Everything from the antenna jack basically to the beginning of the RF amplifier stages, that's your front end. You know, everything from the antenna jack to there and everything in between. So, you know, anything in there can blow and cause a problem. So in this one, like I say, I had basically all of the lower frequency bands. The only band that was, and even it was still reduced sensitivity, but the highest band was working. All of the other ones, just the farther down in the bands you got, the worse it got. And that's just because every single one of those diodes was shorted, and I measured those when I had them out of the radio, and that's what's strange. None of them were burned out. Usually a diode, it'll go almost completely dead short, or it'll go open. They all had different resistance readings. I had 40, one in the 60s, I had one that was like 500 ohms, and I'm talking reverse. It measured the same in either direction, reverse or forward biased. You know, one that was like 500 ohms, one that was like 167, one that was at like 600 ohms. Yeah, that's kind of strange. Maybe that's just a peculiar thing with those BA, what the heck were they, BA243S diodes. And they're nothing special, they're just fast-acting switch diodes. So, who knows? But that fixed this one up. So, I hope you enjoyed, and if you have one of these, maybe you got some tips out of it that can get yours working again.